Hello everybody and welcome to Chapter 2 in our book Elementary Statistics. In this chapter we'll be talking about organizing data. You'll recall that in Chapter 1 we talked about getting data itself. We talked about the ways that we could gather data, where we could get our samples as opposed to populations, and methods for finding samples that would randomly that would fairly represent the population in which that data was gathered. But once we get that data, the question now becomes, what do we do with it? How can we start making sense? It's fine if we have 5 or 6 numbers, and we've seen a few examples in the first chapter where we used a very small data set, but what if we had a very large data set, and how could we gather information from that? And one of the most basic things that we can do is to organize that data. Tables, graphs, charts are all examples of things that we use in order to make sense of the data. So in this chapter we'll be discussing, first of all, classifications of data, and then moving into how we organize that data into tables and how we organize it into graphs and charts. So we'll start with organizing data by talking about the idea of variables in data. How do we actually classify the data that we use? In order to be able to understand the data that we're presenting, we want to know something about what type of data we're presenting. So we classify data the following ways. We say that any time that we express a value in statistics, we're expressing a characteristic about a variable. And a variable is a characteristic that might vary from one person or one thing to another person or another thing. So for example, if we talk about hair color, some people have brown, some people have blonde, some people have black, some people are bald, some people have gray. I have a little bit of both, but it doesn't matter. When we talk about a characteristic that varies from person to another, we could say that the variable in discussion here is hair color. And that's an example of a variable. There are many others. Now, when we get a variable, the question is, what kind of variable is it? Well, there's 2 general types. Qualitative, which is non-numerically data, it has a quality about it, and quantitative data, which is variable that has a numerical that has a number attached to it. And a good way to think about the difference between qualitative and quantitative is that qualitative data is the type of data that we can, well, maybe do some mathematical things about, whereas the qualitative variable is one that we cannot. Now, quantitative variables are divided into 2 other categories. There's discrete and there's continuous. Now, the difference between these two is that when we talk about a discrete variable is one that can be listed one by one. In particular, the quantitative data with only a finite number of possible values. What does that really mean? If I were to count the number of people in this class, or I were to count the number of children in a household, those always come in whole numbers. You will never get half a student or half a child, right? God forbid somebody has half a child. We're going to call the authorities right away. We don't want to do that. A discrete variable is one which we always count by whole numbers, right? So we think about things that can be counted in whole numbers only and never in little parts, right? If I were to go out to the store and buy boxes of rice-a-roni, nobody's going to sell me half a box. I have to buy the whole box or no box at all, so I count those discretely. Continuous variables, on the other hand, are quantitative variables whose possible values can range in between. If I ask you how many miles it is you have to drive to get to New England Tech, or if I asked you how many hours a day do you spend doing your homework, well, we might actually have some variable time with that, and we can give that over a range of values. Somebody might spend 2.1 hours per day. Somebody might spend 0.57 hours a day, right? We can give a range of values between the whole numbers, and so we consider that kind of variable, generally speaking, continuous. Now, there's some play in between those. For example, in American shoe sizes, we have half sizes. Those half sizes, right, if I say I have a shoe size of 9 and he has a shoe size of 9.5, well, then that is a half step, but it's still discrete because we don't offer shoe sizes in between 9 and 9.5, or 9.5 and 10, and so on. So that could be considered discrete. Don't always go by the decimal, go by the nature of the data. So to help organize this idea a little bit further, here we are. Whenever we're talking about a variable can be divided into either quantitative or qualitative. Okay. So we have qualitative and quantitative right here. Let me get my little pointer. Here we go. Qualitative is a subset of the category of variable, and quantitative. Well, quantitative is further divided into whether we're talking about discrete or continuous variables. Okay. So you'll notice that qualitative, we don't really have any subcategories here that are of much use to us in making this sort of categorization. Now, data itself talks about the values that the variable takes on. So when I talk about hair color as a variable, that's a qualitative data. That is qualitative variable numbers like brown, red, blonde, black, red, whatever the hair color is, that is a value of that qualitative variable. Right? So the data itself are the numbers or the values that the data takes on, that the variable takes on. Quantitative data, of course, goes along with what we said about quantitative variables. Values of the quantitative variable are numerical speaking, and they're either discrete, that is, they are discrete whole number values, or they are continuous values that go over a range. So let's talk about it here in this example, and this is really the first question on your handout, and we'll go through and answer this. So right here we've got some information in a table, and this table gives us information from the World Meteorological Association on following data on the highest recorded temperature on each continent. So what do we say right here? Well, the rank in the first variable, right, in the first column, it says what type of data is presented in this first column. So let's go through it. Rank. What could we say about rank? Well, first of all, we can consider rank to be discrete quantitative variable, right? Because if it's discrete and quantitative, I'm going to write this down right here. I'll get my pen going. Here we go. We have discrete and we would call it quantitative. Now, in this particular case, it actually falls into a special category of quantitative values because that quantitative value is rank. And sometimes we subcategorize that and we call it ordinal because it's data that can be ordered by rank, right? In other words, the highest temperature, rank number 1 highest temperature is North America's Death Valley at 134 degrees, while the lowest rank value was Antarctica, with a Vanda Station, Scott Coast of 59 degrees Fahrenheit as its highest on that continent. Very interesting right there. So we say, okay, let's talk about our second column. What sort of data is presented here? Well, sure enough, you know that this is qualitative data. The qualitative data in this case is a place. It's the continent. So our qualitative data is the kind of data that gives us a quality. It gives us a place in this case, right? The quality is a location, right? So we're talking about a continent. And of course, the next column right here in the, let's see, the second column. So this third column would also be qualitative, right? I'll try and make that a proper A there. The third column is qualitative, but let's go to this fourth column now, right? What information is presented there? Well, now in this case, this is most certainly going to be quantitative data. And we see it being quantitative because in this case, we're taking our data and it's numerical, right? Now, here's a question. Would this quantitative data be continuous or discrete? Well, let's see. We're using whole numbers right here. So in the sense that we have whole numbers shown only, we would consider that discrete. However, we know that if we've got a digital thermometer or certain kinds of thermometers that are very, very accurate, we're actually going to get decimal places within our temperature. And when they talk about things like global warming or climate change, if you are we're not talking about opinion here, right? When they give temperatures in tenth or hundredths of a degree. So in that sense, when we talk about temperature, we better add that on, that this is actually considered continuous data. Right? Temperature can be considered continuous for the sake of it being about data that is, can fall within a range, right? And it doesn't have to follow that whole number. Now, the type of data that's provided by, what type of data would we say is provided by the information that Death Valley is in the United States, right? So here it is, right, in North America. What kind of data is provided there? Well, if we're looking for that data right here, we would still call it qualitative, right? Qualitative data, even though it falls within another piece of our qualitative, there we go. I'm going to try and spell that correctly for you. Qualitative data is the kind of data that falls within the category of non-numerical data, right? USA. Now, we could say, if we wanted to, we could call this place data. Another word that we sometimes use for qualitative data is that we call it nominal data. It gives us a name of a thing, right? Like a place, like the United States. We call that nominal data sometimes. So there's a number of different categories that we use that we did not really discuss. But for our purposes in this section, we're going to stick to the idea of having data either being qualitative or quantitative, discrete or continuous, right? And that's what you need to know.